So now let's look at an example involving the inclusion-exclusion rule. So I want to know how many integers from 1 through 1,000 are multiples of 3 or multiples of 5. So here I'm going to use A to represent the set of integers from 1 to 1,000 that are multiples of 3. B would be the set of integers from 1 through 1,000 that are multiples of 5. But here we can't use the addition rule because there is some overlap in these two sets. And what would the overlap be? So in the end, the union would be the set of integers from 1 to 1,000 that are multiples of 3 or 5, which is what I'm trying to count. And then their intersection would be if something is a multiple of 3 and a multiple of 5, it's a multiple of 15. So the set of integers from 1 to 1,000 that are multiples of 15. So let's start with our set A. We're going to count the number of multiples of 3. So list out all our numbers, 1, 2, 3. And the last multiple of 3 would be 999. So this would be 3 times 1, 3 times 333. So the number of elements here that are multiples of 3 are 333. Now let's count the multiples of 5. The first multiple of 5 is 5. And the last multiple of 5 is 1,000. It's 5 times 200. So the number of elements in the set B is 200. The last thing we need to do now is count how many multiples of 15 we have. Right, so the first multiple of 15 would be 15 times 1. The last multiple of 15 would be 990. It's 15 times 66. So the number of elements in A intersect B is 66. So now we use our formula. I wanted to know the number of elements in A union B. The number of elements of A plus the number of elements of B minus the number of elements of A intersect B. So here 333 plus 200 minus 66 gets us 467. So there are 467 of those integers are multiples of 3 or multiples of 5.